morning, everyone. So I am Ross Little from Eviden, a technical project manager, and I'll go over the self-sovereign identity management that we do within TANGO. Okay, so first of all, looking at the components, we have the SSI wallet, and we have a zero-knowledge proof version of it. Both of the wallets are built on walt.id. They support the issuing, management, and presentation of the verifiable credentials. On the right-hand side, like you've seen in the last presentation, we have a view of the mobile version. So the SSI wallet adds support in this project for the mobile user interface, as well as the original web-based one from walt.id. It's also added in ETSI conformance guidelines into work based on the OpenID for verifiable presentations and OpenID for verifiable credential issuance. The standard version supports the walt.VC, supported with the ES256 crypto proof for interwork with the FIWARE Dataspace connector, but also supports other proofs. The zero knowledge proof version is supported using LDP-VCs. And yes, as I was saying, this is all integrated with the FIWARE Dataspace connector. The latest VC verifier supporting standard JOT verifiable credentials off the shelf. And we both agreed to support the two versions of DID key, so the standard drafted key, but also the DID key supported by ETSI. The modified VC verifier done within this project now supports the zero knowledge proof with the LDP-VCs. So the next component that we support in TANGO is the self-sovereign identity agent, acts as the issuer, and also the authorization server within the OAuth2 flow. And we have the zero knowledge proof version. So the SSI agent supports the issuing of walt.VCs with the ES256 crypto, as we said before, for the wallet also, amongst others. And the methods it supports off the shelf, the key, the web, JWK. The zero knowledge proof SSI agent supports the LDP-VCs with the zero knowledge proof crypto, but also additionally supports a machine-to-machine issuing and presentation of credentials for the autonomous car pilot. Likewise, it's been implemented supporting the ETSI conformance guidelines. And for TANGO, we support the issuing of e-passport, employee credentials, and customer credentials, as well as the machine-to-machine credentials. Okay, here's an example of the JOT verifiable credential. On the left, we see how the JOT is encased in a signed JOT with the signature appended on the end, an algorithm at the beginning, and the payload in the middle. So here we have on the right the payload for an employee credential, and under the credential subject, you see that we have the role information that is used by the policy enforcement that was presented before to get access to different services or not. And we have more information about the employee. Here we have an example LDP-VC. So it's formatted slightly differently. The crypto proof is included inside the credential here, as we see, with the proof value. But we also see the credential subject, as per the standard verifiable credential by W3C. Just to note that the zero knowledge proof, then when it's being presented with the implementation of the BLS signature that we see down the bottom left, is able to hide certain claims when it's being presented to the relying party. In this case, the Dataspace connector. Okay, well, as it is a deep dive, we'll go into the flow of the e-passport issuing. So over here, we can't quite see it. Maybe you can't, but the self-sovereign identity wallet, so the mobile app, and also the ePassport onboarding app, which we've seen presented by Stefanos in the previous presentation, both residing on the mobile, and the SSI agent acting as the issuer and authorization server with the cryptography. Okay, so it's quite an innovative flow because the issuer application is the ePassport app on the mobile. So we make use of deep links to invoke each other's applications. So starting the flow, the end user will open up the ePassport app, and they will click on to issue me with an EID credential. So that's to receive the offer. Gets this offer from the SSI agent, and then we have this is redirected back to the OpenID credential offer, which invokes the wallet on the mobile with this deep link. This will then look up the request with the URI inside the deep link to the agent. Gets a credential offer, and with this, the end user sees that they're not being offered an ePassport credential. Okay, it looks up the well-known information, and with the previous information given in the request object and the offer and the well-known information, it creates an authorization request to the backend agent. The agent responds to authenticate this user making use of their ePassport application. So here we have the ID token request to get ID information and authenticate the user with their ePassport data. The request also is double checked against this, it's a signed request, so it checks against the authorization agent. So then we go into the ePassport app. The user consents with their not to read the ePassport data, follows through all the flow, reading the NFC, does the live face verification against the ePassport image. So once that's all successful, it responds back with the ID token response with all the claims of the ePassport. This again is a redirect back towards the mobile wallet. So following the auth to code flow, it will request an access token, and with this access token, it will request to be issued with the credential, and the credential is received in the mobile wallet. Okay. Okay, so I'll go into deep dive with the organization issuer flow also to get the employee credential. Yeah. Okay. Technical issue here zooming in, so I'll just go over it quickly. So at the top again, the user will go to the let's say passport. The user will go to the intranet of their organization, and they will click on a button to be issued with an organization employee credential. There is presented a QR code in step 6. They scan the QR code, and then they say in their mobile wallet, yes, we accept to get an employee credential. The SSI wallet again looks up the information for the agent there, so it gets the credential offer with the request URI object, and this results in an authorization request again to get this credential. So the SSI agent sees that it's wanting an employee credential and will request for a verifiable presentation of the user's ePassport from the wallet. The wallet will present this in a direct post towards the agent following standard OpenID for verifiable presentations. And then the SSI agent, following the issuer flow, will get the user info from the back end of the organization based on their ePassport number. So within there, they have a database of all their employees against the e-passport ID or national IDs, and returns the claims. So the authorization agent will respond with the code flow again. So with the code, the wallet is able to get the access token, and with the access token, it will request the credential with the claims, authenticated claims previously received from the e-passport verifiable presentation. Okay. So finally, so when we're authenticating, we're making use of the FIWARE Dataspace Connector VC verifier. So we have the front-end application, the actor is trying to access a service, a data service, and this has to authenticate. So here we see this presented next with a QR code with information received from the VC verifier. So in step 3, the wallet will scan that and present their employee credential that they're being asked for. I skipped a step there. So the VC verifier will get that information from the credential config service in the back end there. Basically, it's a map between the data service that they're trying to access and the credentials that are needed to access that. Okay, so once it's presented its credential, the VC verifier will check against the trusted issuers list, which is a list of the trusted issuers. So that the organization that issued that credential was there in the trusted issuer list, and additionally that it's able to issue those types of credentials. So once it's been fully verified, then it will return an access token in step 6. And then with step 6, the user can then proceed to, well, they've seen as they're authenticated and proceed to access the data over the authorization layer. With that, that ends the presentation here. So I will go on to the demonstrations. Okay, so we're going to see 2 demonstrations, one with the issuing of the e-passport credential with the onboarding, now making use of the e-passport application and also the SSI wallet and the SSI agent hidden in the backend. Oh. Okay, so it's all happening on the right-hand side. So this is the credential offer that was first on the e-passport application. Then it chose to authenticate. Okay, with the e-passport application, it selects the e-passport to be authenticated with. The user is from United Kingdom. So now they're going to take an image of the e-passport to scan the machine-readable zone on the passport. We have some privacy-preserving smoke here, so you don't see my data. Okay, so now they're scanning the e-passport with the NFC. There's a live image being taken from the user, which is then checked against the e-passport. If it works, then it proceeds to submit to the issuer. This is a redirect back to the wallet, and the user has now the e-passport. And here we see the credentials and the user information inside the wallet. Okay, perfect. Okay, I'll go on to the next one. Okay, so now we're on the relying party organizations intranet, and the user includes their ePassport ID, and they're given they're recognized in a database of valid users. So then there's given a QR code with the offer that was obtained from the SSI agent. The wallet is now scanning it, and they have received the employee credentials. So it's a very quick way to get credentials for users from inside their organization's intranet. Okay, and that concludes the deep dive on the self-sovereign identity.